In this video, I will show you how to solve word problems using matrices. And we will be using the TI-84 to assist us. In this video, I will show you how to use matrices to solve word problems using a graphing calculator, in this case a TI-84. So a theater has a seating capacity of 900 and charges $2.50 for children, $4 for students, and $5.50 for adults. At a certain screening with full attendance, there were half as many adults as children and students combined. The total money brought in was $3,825. How many children, students, and adults attended the show? The last sentence is very important because it tells us what our variables need to be. How many children, students, and adults attended the show? So we'll need a variable for each one of those. So let's let x equal the number of children. Whoops. And we will let y equal the number of students. And we will let z equal the number of adults. All right, so the first equation is going to be rather simple. It's just going to be an equation of the total amount. So we know that x plus y plus z, that's the total number of children and students and adults. If you add those all up, it was a full house and the capacity was 900. So this will have to add up to 900. That is simple. Now we need to find two other equations. If we have three unknowns, we're going to need three equations. So sometimes I will call this equation the quantity equation. All right, it's like the total amount. Now, next, I think we are going to have a money equation, which is very common. All right, so we have the number of students and children and adults, but now we need to talk about the money raised from children and students and adults. So, since we are charging $2.50 per child, the money will be $2.50 times the number of children. That will be the amount of money from child tickets. Since we're charging $4 for students, then that's going to be 4 times the number of students will be the money from student tickets. And we are charging $5.50 for adults. So $5.50 times z, that will be the amount of money from adults. If we add the amount of money from children, tickets, student tickets, and adult tickets and add it all up, that should be the total amount of money, which we are told is $3,825. So that's two equations. We need a third equation, and so sometimes they just will throw in a random third equation. So I'm just going to call it rando third equation. And where is the random third equation? It's right here. They say there were half as many adults as children and students combined. Now this can be pretty tricky, so pay careful attention. Here's how I like to think about it. We are comparing two things, adults and children and students combined. Those are the two things that we are comparing. So on the one hand, we have adults, and on the other hand, we have children and students. All right. Our goal is to make an equation. So we really want to put an equal sign right here. But these two quantities are not equal, so we're going to have to modify this. So I'm going to come back to that. We're going to have to fix this. First, we have to decide which of these is more. Are there more adults, or are there more children and students combined? Well, it says there are half as many adults. So I think we will agree that there are fewer adults. And that means that there are more children and students. Now, the reason why I'm emphasizing that there are fewer adults and more children and students is because a common mistake is to look at this blue sentence that says half as many adults, and people will think, oh, okay, so I need to do half of the adults, and that will equal the number of children. So I will see this equation very often. Let's see, adults are Z. So I will see the equation 1/2 Z is equal to children and students. That's X and Y. So 1/2 Z is equal to X plus Y. This is wrong. Totally wrong. And I'm trying to get you to understand why this is wrong. So if we agree that there are fewer adults and that there are more children and students, if we focus on the fact that an equation means that the two sides are equal. If I take the side that already has fewer and I cut it in half, is that going to solve the problem? Will that make the two sides equal now? No, that makes the problem even worse. I took the side that was fewer and now I've made it even less. Instead, I need to do the opposite. If this is the side that's fewer, if I want the left side to equal the right-hand side, instead of dividing by 2, I need to multiply by 2. If I double the amount of adults, that will equal the number of children and students. Or I could have said half, I could have put the 1/2 over here, half of the children and students. So hopefully this makes sense. I take the smaller quantity, double it, then that should equal the larger quantity. That makes sense. So that's why the correct equation is going to be 2Z is equal to X plus Y instead of 1/2 Z, which was totally wrong. Now, of course, we need to rewrite this in standard form. One way to do it would be to subtract 2Z from both sides. All right, that would give me 0 is equal to X plus Y minus 2Z, which would be the same thing as having X plus Y minus 2Z equals 0. All right, of course, I could have subtracted X and Y instead, and that would give me negative X minus Y plus 2Z equals 0. And that would also work. So now it's time to write the matrix equation. So I will take the coefficients and I will write 1, 1, 1. And then the next equation brings me 2.5, 4, and 5.5. And then the third equation will be 1, 1, and negative 2. So this is the first matrix, the coefficient matrix. Next, I write the variable matrix, x, y, z. And I will set that equal to the answer matrix, which is 900, 3,825, and 0. So we must label these matrices. So
I will call this matrix A, I will call this matrix X, and I'm going to call this matrix B. The following statements are mandatory and they cannot be skipped. So we're going to do a lot in our calculator, but this small amount of work you have to show. Here's our matrix equation. Matrix A times matrix X equals matrix B. In that case, matrix X will equal A inverse times B. All right, so this must be shown. Show your work. But the rest will be done on the calculator. So let's type matrix A and matrix B into the TI-84. All right, so we will go to the matrix area, go to the edit menu, and we will edit matrix A. Okay, so we have 1, 1, 1. So that part's going to stay the same. All right, now I have 2.5, 4, and 5.5. And then I have 1, 1, negative 2. So that's matrix A. Quit your way out of the matrix. And now let's enter matrix B. Make sure it's a 3 by 1 matrix. 900, 3,825. And 0. Quit your way out. So what we want on the calculator screen is A inverse B. So go to the matrix area, hit enter for matrix A, hit this button to make it the inverse, go back to the matrix area, go down to B. Now we have A inverse B. Hit enter, and these are the answers: 150, 450, 300. Okay, and of course that means that X is 150, Y is 450, and Z is 300. But because this is a word problem, we can't just leave our answers like this. We have to put our final answer into a sentence. So your final answer should be something like this: 150 children, 450 students, and 300 adults attended the show. All right, so problem number 3. A sporting goods store sells footballs, basketballs, and volleyballs. A volleyball costs $35, a basketball costs $25, and a volleyball costs $15. On a given day, the store sold 5 times as many footballs as volleyballs. They brought in a total of $3,750 that day, and the money made from basketballs alone was 4 times the money made from volleyballs alone. How many footballs, basketballs, and volleyballs were sold? The last sentence is super important because it tells us what the variables need to be. All right, so let's start with that. Okay, so how many footballs? So we're going to let X be the number of footballs. We'll let Y be the number of basketballs. And we will let Z be the number of volleyballs. All right, we have 3 unknowns, so we're going to need 3 equations. So let's scan through here looking for our equations. If they were nice, they would give us the quantity equation, where they're like, there's a total of 450 of all the different kinds of balls. But this time, they were not nice. They did not give us a quantity equation at all. All right? I see money, though. So we should be able to make a money equation. So let's go ahead and set up a money equation, which is very common. I really wish I had that quantity equation, though. Money. So let's see. $35 per football. So that means 35x. That'll be the money made from footballs. And then similarly, so plus 25y. That's basketball money. And then plus 15z, which will be our volleyball money. And that should equal the total amount of money, which is what? All right, $3,750. All right, have I lost anyone so far? Are you comfortable with the money equation? Okay, now here's where it gets painful, because that was our only sort of common sense equation that they gave us. This time we will have not one but two random equations, okay, that they just throw in willy-nilly. So here comes random equation number 1. Let me highlight it in blue. Let's see. The store sold 5 times as many footballs as volleyballs. All right, this one is not as tricky as the one we were just working on before I started this video. You would probably guess this one correctly. I'm still going to go through my little analysis. We're comparing the number of footballs. We're comparing the number of footballs with the number of volleyballs. All right, I'm going to temporarily set them equal to each other, knowing that this is wrong and I have to fix it. Look at the blue. Which is more? Footballs or volleyballs? Which is more? It says 5 times as many footballs were sold. So can everybody agree that there's more footballs? Okay. So where do I need to put this 5? If I want to throw a 5 in the equation, where's it going to go? It's going to have to go on, where does it go? On the volleyballs. Is that what you guys were saying? Yeah. Okay, because child in the front row who probably doesn't want her name to be said on this video. So we have more and we have less. Okay, right. But we're trying to make an equation. So the left side and the right side have to be equal to each other. So if I'm going to multiply anything, I need to multiply the lesser one to make it equal to the larger one. So can we agree that I will have to do, the footballs will equal 5 times the volleyballs. Okay? So that means, so footballs was x. So that means x is going to equal 5 times z. Right? Okay, so you probably would have guessed that one. It wasn't as weird as the last one. So if I subtract 5z from both sides to put this in standard form, can everybody see that I'm going to have x? I don't have any y, but I'll have minus 5z is equal to 0. Did I lose any one right then? Okay, you look good. All right, now let me erase this little scratch work here. I'm going to need this space. So we have one more random equation coming. The second random equation is the one that's going to hurt your feelings. You're going to feel betrayed, is what it is. The phrase, the word unfair is going to pop into your mind. Okay? You're going to be tempted to ask, are you really going to put this on the test? Are we going to have one like this on the test?
And the answer is going to be, better be ready for it. Solemn nod indeed. Okay? So emotionally prepare yourself for that. Okay, let's see. Let's highlight the second random equation in blue. Okay, money made from basketballs was 4 times the money made from volleyballs. Okay? Now, at first glance, this doesn't seem that bad. All right? It says, okay, hold on. We're comparing basketball money, and we're comparing that to volleyball money. Okay, which of these is more? Which of these is more? Okay, let's see. Money made from basketballs was 4 times the money made from volleyballs. So can we agree that the basketball money is more? Does everybody agree on that? And the volleyball money is less. Does anybody want to argue about that or question that? Okay, so with that in mind, now you're still going to make half of you are still going to make a mistake right now. All right, does anyone want to volunteer to make the mistake for us all so we can all discuss the mistake? What do you think the equation, what does it seem like the equation would be, Robert? Okay, because money made from basketballs is 4 times money made from volleyballs.
I was thinking that it was going to be, it would be like 4 parentheses, or no, like 4 parentheses 25 is equal to just 15 and 15y.
You're super close. You're closer. I'm pleased with how close you are. You're almost correct. Okay? So look, which one of these do I need to multiply by 4? Let's get that out of the way first. Okay? I need to multiply the volleyball part by 4. The part that a lot of you would have missed if I weren't emphasizing it to you right now is that we are not talking about the number of basketballs. We're not talking about the number of volleyballs. So we cannot simply say y equals 4z. That would be wrong because y is the number of basketballs and z is the number of volleyballs. We're talking about basketball money and volleyball money. Okay? And that's why Robert was correctly mentioning the number 25. Okay? See how we have the money equation? Let's look up here and remember what we said about each part. Robert is looking right here and he's saying, look guys, this part of the equation is basketball money. 25y is, 25y is basketball money. 15z, this is volleyball money. So instead of just putting y, we need to put 25y, okay? And instead of putting just z, we need to put 15z. Correct. Okay? Does that make sense? Okay? I feel like that's about as hard as it gets. Did you understand that one? So someone person in the front row remaining nameless is not sounding super confident.
You said my name.
Yeah, you seemed like you wouldn't mind.
Okay.
So right, you didn't ask me at the beginning. Well, wait a minute, can you edit me out?
I'm famous now in Puerto Rico.
So this is going to be 60z. So if I rearrange this in standard form, I'm going to wind up subtracting 60z from both sides. So this is going to give me, let me switch back to purple. because OCD. So I'm going to have 25y minus 60z is equal to 0. All right. So let's follow through and actually solve this one using matrices. Okay, so we can make our matrix equation now. And the matrix equation will be 35, 25, 15. Those are the coefficients. And then from the x, I'm going to get a 1, and then 0, because there's nothing, and then negative 5. And then 0, 25, negative 60. So that's my coefficient matrix. Next comes the variable matrix, which will be x, y, z. And then I have the answer matrix, which is 3,750, 0, 0. Okay, let's call the first matrix A, and you have to label these for the next step. You have to label these. So let's call this A, let's call this one X, let's call this one B. All right, so what I'm about to write next is not optional. I need to see it every time you do a matrix equation. Every single time. I like that reinforcement. So now, because I labeled them, I can say, okay, AX is equal to B. Do you know what I'm going to say next?
You're going to say x is equal to b times the a to the negative 1.
A inverse, yes. Okay, so I'm going to say x equals A inverse times B. And we're going to use our calculator for this, right? So work-wise, this is all you would have to show. So now we can just use our calculator. So let's start by typing in matrix A and matrix B. Okay. Someone get ready to read me matrix A, please.
I got you.
So let me just get over to the edit menu. Wait, is this that's it? Okay. Never mind.
That's convenient.
Yeah, because I was just working. This was the one that got deleted, and I'm doing it for the second time. All right, so type in matrix A. Make sure you quit your way out of matrix A. And then you go back to the matrix area, go to edit, go down to matrix B. All right, type in matrix B. Make sure it's a 3x1 matrix. Quit your way out of that. Go back to the matrix area. Remember, we want A inverse B on the screen. So if I just hit enter right now, that gives me A. Hit the button that says x to the negative 1 power, that makes it A inverse. Go back to matrix, go down to B. So here's A inverse B. So that gives you the answer, 75, 36, 15. 36, 15. All right, so obviously that means that x is equal to 75, y is equal to 36, and z is equal to 15. But for full credit, you can't stop there. This was a word problem, so you need to put your final answer in words. So your final answer should look like this.